Dynamic host configuration protocol. This is one of the network service that provides IP address. What is the benefit of providing IP address through DHCP server? Number one, we no need to log into every single tens and hundreds and thousands of device to provide an IP. As the device comes online, they receive an IP address. So dynamically, the hosts are configured with an IP address using this protocol. Dynamically, it may be 10 hosts, it may be 100,000. All these computers, sometimes printers, there may be many devices in the network. They all get IP address dynamically as they come online. That's one advantage. It reduces our human work. Secondly, when DHCP provides IP address, there cannot be a duplicate address seen. Every device will have a unique IP address. There won't be a duplicate address. If duplicate address is configured, what happens? Conflict. So DHCP services provides unique IP address. So there is no way, there is no chance for a DHCP server to give same IP address to two different device, two different hosts. Why? DHCP provides an IP address by taking their MAC address. When the MAC address is different, IP address given will also be different. You see, we got a client, DHCP client. What does that mean? This computer, it depends on the server for an IP address. So we got a server, which is a DHCP server that is also connected to the same LAN where the client is connected. There is another client. Client 2, client 1. So you may have tens and hundreds of thousands of clients. They all need an IP address. They receive an IP address from a DHCP server. So the DHCP server will have an IP address statically configured by us. Let us say the IP address is 192.168.0.1/8. If this is the IP address of the DHCP server, and let's say you got a router here which is connecting to the internet. A public IP address is given by your ISP, and on this port you will be having a static IP address 192.168.0.2. I'm sorry, I put 8. It's not 8, it is 192, no? 24. So in this network, in this local area network, LAN, I have given IP address statically to two devices. One is a DHCP server, another one is the gateway. Isn't it? Router's address is what? Gateway for all the LAN connected device, all the hosts in the LAN. Router's address is what? Gateway. Now, you can configure a DHCP pool in which you can say IP address starting from 192.168.0.1 0.3 onwards. See, because 1 and 2 we have already used. From 3, you can say any range, like 192.168.0.100. So there are 97 IP addresses in this range. And when a client comes, the first address will be given. When the next client comes, 04 will be given. And when the third client comes, 05 will be given. So for every client, there will be an IP address given from this DHCP server's address pool. So we create this pool. DHCP provides an IP address, not just IP address. It can also tell all these computers that your gateway is 192.168.0.2. It can even supply the gateway address. See, the gateway address we only statically configured on the router. We also tell server to distribute this info, distribute the IP address of the gateway of the router as a gateway to all the LAN devices. DHCP server can also provide DNS address. Let's say you are configuring a DNS server address like 8.8.8.8. So this also will be given to all these computers. For example, when this client receives an IP address, it receives 192.168.0.3 and the gateway has 192.168.0. The gateway, this one, and also along with the mask 24, and also it will get DNS address. So client 1 received a valid IP address with the gateway and the DNS. Now this DHCP server, when it sends a request, when this client sends a request, it gets another IP address, 192.168.0.4. The gateway is 192.168.0.2. And then the DNS address is 8.8.8. Likewise, hundreds, thousands of hosts can get IP address if address is available in the address pool. But in our pool, we got only 97 address, starting from 3 till 100. So if you will have computers less than 97, they all will be getting a unique IP address. If you have more than 97, what will happen? They won't get. For example, you see, we have 3 computers, but I just say 4. So 3 is given, 4 is given. Already all the addresses are given from the pool. There is no address to give. What will happen to this client? When this client comes online, the server has got no address to provide. So it won't provide. So this client, it will wait. At last it will say 169.254, some number. This is what called as APIPA. Automatic Private Internet Protocol Address. This 169.254 is not a valid IP address. It's an address that is telling you that DHCP server is not in a position to provide an address. Or it is telling that server is not providing me an address. So the client says, server is not giving me address. To tell that, it uses this automatically generated by the operating system called APIPA, Automatic Private Internet Protocol address. 169.254. So there are many reasons why you get 169.254. Number one, this wire is disconnected and there is no server reachable. That's one reason. Second reason is there is no address in the pool, which we just now saw. Third reason is in this port, someone is blocking the DHCP reply. What if in this port someone configured a block saying if any DHCP reply is coming, don't allow? So if one of this reason is there, you will not get IP address. So that's APIPA. Now let's go back to our DHCP topic. APIPA is over. Now we have enough address in the pool. Not just two. We got another, let's say 10 IP address in the pool. 192.168.0.3 to 192.168.0.12. Totally 10 IP address I got. So when the third computer comes, the client is going to receive an IP address. It will be like this: 192.168.0.5. Mask is 255.255.255.0, and then the gateway is 192.168.0.2, and then the DNS address is 8.8.8.8. So dynamically, address is getting assigned, and there is no duplicate. The addresses are leased for 24 hours by default. You can change the lease time if you want, optionally. Now what will happen after 24 hours? If this PC is still on even after 24 hours, it will just go with this address and say, hey, I'm already having this address given to you. Can you renew me? Can you renew this address for me again? And it will renew another 24 hours. So this renewing address also happens dynamically. You don't need to do anything for this. See what a wonderful protocol, wonderful service is DHCP. And this DHCP uses UDP. 68 and 67. 68 will be the port number. So if a client sends a packet, the source port number will be 67 and the destination port number is 68Y because it is talking to the server. Server port number is 68. UDP. DHCP uses UDP 67 and 68. Okay. So this is what the basic, the first round of DHCP. Now this DHCP that you are seeing is a server maybe running on a Windows platform or Linux platform. You know one thing, a router can also be a DHCP server. So instead of this Windows server and Linux server, you can have a Cisco router or a switch, layer 3 switch, to be a DHCP server. Yes. Okay, this is one scenario which we are going to do. We'll have one router here which is connecting to the ISP as a gateway, and we'll have another router here as the DHCP server. This is the first scenario. Second scenario is our DHCP server will be somewhere remote, somewhere, since it's not in the same local area network. It is not connected to the same switch where the hosts are connected. The DHCP server is somewhere means connected in different LAN, not on the same LAN. What I mean is we got a lot of computers and it is connected to a switch, LAN device, and you may have a router which is connecting to the ISP. Now you also have inside router. This is edge router connecting you to the internet. You have another router here, and behind this somewhere here, it may be on a Windows machine or a Linux machine or a Cisco router. You got DHCP server. In the previous diagram, DHCP server was right there on the same local area network. But in here, we got a DHCP server behind a layer 3 device, behind a router. Now we need to understand how DHCP will work in this environment and also in this environment. DHCP in two different environments we are going to see. First of all, we'll focus on this. But before doing that, I want to say something here. See, because DHCP server is here, we'll configure on this port telling this router that there is a server behind you like this in this side whose address is this one. So you need to tell to this port, you need to help by using this address 172.16.01. You need to go get the DHCP IP address and give it to these computers. We call it as relay agent. So we're going to make a router which is having the route to reach the DHCP server as a relay agent. We use the command called IP helper address 172.16.01 to do this. So more about the second scenario later. I just want to introduce you an agent who can go and get the IP address for you. But there is no need for an agent here. Why? Because the server is in the same switch, local area network. Now, let us try understanding how an IP address is received in a computer. For that, I would like to draw again another diagram here with just two computers. You got a server, you got a client one, you got client two, this is DHCP. What happens first is A layer 2 broadcast sent from the client to a broadcast address. It's a layer 2 broadcast packet. Who is sending? Clients are sending. As soon as you turn on this computer, they send a layer 2 broadcast. Because it's a broadcast, I'm writing any. That's the destination. It don't know the server. And this broadcast packet is what called as discover packet. It's a discover packet. The very first conversation is not from the server, it is from the client. The very first conversation is from the client. Looking for a server. That's why it is sending to everyone. That's the reason I said destination as any. The destination MAC address is FFFFFFF 12 times F, which is called as layer 2 broadcast. This will be the destination address. The source address will be, the source MAC address will be the client's MAC address. Client's MAC address. Every client will put their own MAC address as a source and the destination address as layer 2 broadcast address. They send this packet called discover packet. And this discover packet will go to everyone. For example, when this packet comes, because it's a layer 2 broadcast, it will go here. And this is a client. He will not respond. He will simply drop it. But the packet that goes here will be received and processed. Whereas this guy client, he receives it, but he won't process it because it finds that the payload is for DHCP server. It finds that data inside and know that this is not for me. So I'm going to drop it. So the broadcast that went here is a waste. But the broadcast that went here will be responded. So now the server is going to do a unicast. It may be surprising you. Yes, it is a unicast. With the source address of the server and destination address of the client. Surprisingly, okay, let's say the server's IP address is 192.168.0.1. You will see a source address of 192.168.0.1 and the destination address you will see 0.2, which is an address from the pool. Now you need to think something here. Wait, this guy don't have an IP address. He wants an IP address. He's looking for an IP address. How can server send a packet to this guy, this address, when this address is not given earlier? You understand what I'm saying? This address is not given earlier to this client. How can server provide this as a destination address of the packet? The truth is, yes, it can send the destination address. It will fill the destination field with this address, which is a kind of proposal. It is just proposing, hey, if I'll give you, this is what the address I'll give you. You see, this is the first packet, Discord packet. It was a layer 2 address as a broadcast. Not only that, the layer 3 of this packet was like this, source is 0000, because you don't know any IP address. And the destination is 255, 255, 255, 255. This is what the discover packet was looking like. There is no source IP address. But when the server responds with offer packet, this is called offer, coffee, college, okay, that offer. This offer packet, when an offer is given from server to the client, this offer looks like this. Server's original MAC address, client's original destination address, server's original IP address, and the address which is a proposal. Server is responding as if it received packet from 192.168.0.2. Did it receive from packet 192.168? No, it was receiving from 0000. But now it says, I'm talking to you, your address is this. Client will say, okay. Anyhow, my MAC address is matching. So let me receive this as a proposal to me. Client receives the proposal. Okay, fine. It looks like a nice number, fancy. So let me try giving a try. So the offer was coming from server to the client. Now this client, again, with a source MAC address, C1 means its own MAC address, destination MAC address, not the server's MAC address. Again, it's layer 2 broadcast. See, it knows the server's MAC address. Why it's not putting server's MAC address? Because what if that server is down? What if there is another server you prefer? Something like that, So this is not going to be a unicast because it don't have an IP address to do unicast. Still, it is just a proposed address from the server. Client has not received it, accepted it yet. Client says, okay, your proposal is interesting. Let me send you a request. So still it has not started using what has been proposed. So again, if you see, it's a layer 2 broadcast only. Client is sending a broadcast. Hey, I'm requesting you to give me the address that you proposed. I'm requesting you to give me the address that you proposed to me. For which the server will now provide acknowledgement saying granted. Granted, you may use it. And that comes as a unicast again. Source MAC address is server's MAC address. Destination MAC address is client's MAC address. And then the IP address is same like this. Whenever server talks, it puts the proposal address and source address. So this is a unicast. Try to understand this. The packet going from client to server is a broadcast. The packet that is coming from the server to the client is a unicast. These are the 4 packets that are exchanging between the client and server to get an IP address on this machine. 4: discover, offer, request, and acknowledgement. Anyone has got any question? Right. If no question, let's quickly get into the R1 is as a server, R2 as a client. Just 2 routers I have taken so that when you capture, you will see only those packets going between these 2 devices. If I take more device, then more packets will go, then you will not know which packet is from whom. Yeah. So on the client side, we are not going to give any IP address, but you need to make it as a client. What is making as a client? Going to this interface and saying, hey, I'm not going to give you an address. You need to take the help from DHCP server. That's what making it as a client. On the server, I'm going to give an IP address statically. Let us say the address is 172.200.1/24. This is actually class B address, but I have taken all 3 octets. That's why 24. That is to show you that a DHCP server can give IP address even a classless prefix length. All right, so I'm going to create a pool, and that pool will have 172.16.200.100 onwards. I don't want to use 2, 3, 4, 5, 6. See, 1 is already used. I'm saying the pool will be having 100, so it will throw address only from 100. For the first client, it will give 100. So I have 100 to 150. So totally, let me say 101. So totally 50 IP address I'm placing in the pool. Assume that there is a router somewhere, and I have a switch in this middle, and that router's address is 172.16.200.50. This is the address of the gateway, a router. Assume that you have a router here, and that router is connected to the internet. So when DHCP provides IP address, I want the DHCP to provide even this gateway. Surprisingly, you will see client, because I'm using the router as a client. How will the gateway look like? It will look like a default route. You will see a static default route dynamically written. See, what is static? Manually writing. But you will see a DHCP server given information will be entering into routing table like a static route. I'll show you all these things. Now, first going to the client side. Show IP interface brief. You see, there is no IP address on 3/0. It is administratively down. Let me sniff the packet before I do anything more. Okay, so the packet capture will capture some packet info, layer 2, layer 3 info, and show you. Right now you don't see anything because I have not said no shutdown on any of this port. Now, please pay attention closely. I'm not going to give any IP address on this router. I say no shutdown, and then I'll say IP address DHCP. That's all. I'm saying take it from DHCP. Boom. All right. Now, show IP route. Do you have any route? Nothing. Show IP interface brief. Do you have any IP address? Nothing. But I have said the method of getting IP addresses from DHCP. The DHCP service will provide you. That's all on this router I have configured. By this time, router 2, see, it started sending a layer 2 broadcast. Listen to this packet. It is called as discover packet. You see, I click on this first packet. It uses the source MAC address as its own MAC address. Who is sending? See, as of now, I said no shutdown only on this interface, only on this port, not even on the server. Server is not even touched. So this is the MAC address of the client, ending with 54. Okay, client. It is sending a layer 2 broadcast, and you see the source IP address 0000 because there is no IP address. And you see it is sending to a layer 3 broadcast address. And if you go down, it's a UDP packet. And this is the client side. Sorry, the client side is 68. The server side is 67. So the client is saying, I am client. How? By putting 68. And it is sending to the destination port number 67. Now, whose port number is 67? Server's port number is 67. I repeat, initially I made the opposite. I said opposite. 67 is the port number of the server. So when you talk to server, it should be 67. Okay, so 67 is the port number of the server. 68 is the port number of the client. So when I'm sending, if I'm client, I'll say I'm source 68. Okay, now what does the discover packet says? If you see here, it is requesting for an IP address. It says, hey, my MAC address is this. This is my MAC address. I don't have any IP address. No. So if you have IP address, give me. If you have a house name, give me. I'll take all these things if you give me. So it is sending a Discord packet. But so far no DHCP server, so no reply. Let us now go to the DHCP server. On the DHCP server, as I was saying, first of all, I need to go to interface G3/0 and put an IP address statically 172.16.200.1.255.255.255.250. Okay, this is done. What else? Now I need to create a pool. IP DHCP pool, give a name. I'll say LAN 1, something like some name, and hit enter. You are inside the DHCP mode. Now here you need to use the keyword network. Using the network, you can create the range, you can tell the pool address, range of address. We are going to say 172.16.200.101 and I made a mistake. No, I'm right. Okay, so we say network, and then the mask is 24. Space 24, and then wait a minute, where is the range? I want to give the range. Network 172.16.0 sorry 1200. You can use /24 or you can type the mask. Okay, anyway, starting from here, it is going to give, there is no range in this operating system. Starting from here, it will give. Next is, I told you there is a router, there is a gateway. So we say default router. So this is the IP address of the gateway, the edge router. I asked you to assume that we have a router. I'm saying 172.16.200.15. This is the gateway. Next is you can also give DNS address, something like this. That's all. We have enabled DHCP server also. Just create the pool, that's all. Now, if you type show IP DHCP binding, look at this. You already see it is given 2. But we said starting address should be 101, but the problem is I did not do with the mask. So in this operating system, you need to play with the mask to reserve up to 100. So anyway, let me do one thing. I'll go back to the pool. I will cancel this and say like this. Sorry, 24. So first IP address, since I have already used the first IP address, it is given 2. Show IP DHCP binding command will show what address is given to whom. Now, because I did changes, there is no binding, it got refreshed. Let me go to router 2 and interface G3/0. I will shut down this interface for a while because it has already received an IP address. I've shut down. Okay. I've shut down the interface, so the address is now gone. I'll say no shutdown. Now again, you will see those DHCP packets. See, an address 172.16.200.2 is assigned. Show IP interface brief. You see an address is given by DHCP server. And also show IP route, you will see now routes plus the default route, the static route. I was telling you, no, this is the address of the gateway. A default route is pointing towards the gateway. Instead of this router, if I would have kept another computer, it would have shown as a default gateway. This route will be seen as a default gateway. See, you remember, yes, star means what? Default route. Did I write this route? No. It came out. Okay, now what is next? Let's go back to the capture. Stop the capture. Okay, now I'm going to show you all the DHCP packet here. In this DHCP packet, I'm not interested in all this discovery, a lot of discovery. Okay, I want to start from here. You see, there was a discover packet from 92, packet number 92. It's a discover packet going with the source MAC address 54, which is client's MAC address, to a broadcast address, and layer 3 address is source is null 0000, destination is 255.255.255.255, and then the port number is DHCP client's port number is 68 and destination port number, server's port number 67. Now if you see the offer, it will be opposite. In offer, the source port number is 67, destination is 68. In the offer, see, it is giving a proposal. It says, hey, I will give you this IP address. I'll give you this IP address. And is it a layer 2 broadcast address? Oh yeah. Offer is also a broadcast in this operating system. See, sometimes it varies. In some operating system, I have seen this as a layer 2 unicast. Anyway, here all 4 packets are broadcast. Discover, offer, request, acknowledgement. Now this one, if you see, this is the offer coming from server. But here happens to be 54, same 54. But not the other portion. See, other portion is different. Here it is E60054. It is 05F554. They are not same. Okay, so this is the server's MAC address E6. E6 is sending an offer. Now, still, the IP address, the proposed IP address is not taken. That's why next packet, if you see, it is 0000. Who is sending the request? Client. Client is sending the request. You see, F554 sending a request. It is requesting, saying, okay, fine, I'm okay with this IP address. I'm okay. Let me have this IP address. Give me. So it is sending to this server, particularly, and it says, hey, this is my MAC address. You can take my MAC address. Give me confirmation that I can use this 202 as an IP address. So the confirmation is coming in the next packet, acknowledgement, which is also a layer 2 broadcast, where it is leasing the packet here. You see, it is leasing for 24 hours, one full day, 86,400 seconds lease time. It has leased the address. Who has leased the address? The server has leased the address to me, to the client. All right, and that's how the IP address is taken. Now you see, it is received in the client has received an IP address. I shut down the port, so it has released the IP address, and again, the discover, offer, request, acknowledgement came and started using. This is how DHCP works. So what we have seen today is DHCP is a service that provides an IP address dynamically to all those clients who ask for an IP address. And this service runs on UDP 67 and 68. 68 is the client side, 67 is the server side. And there are 4 packets: discover, which is a layer 2 broadcast going from client, and then offer, which is from the server to the client, in which an IP address will be proposed. And then the third packet is request, which is going from the client to the server, which is also a broadcast, layer 2 broadcast, requesting for the IP address. And then the acknowledgement is the one which is leasing the IP address with the same IP address requested, which is also a broadcast. 4 packets: discover, D, offer, O, request, R, acknowledgement, A. Do you know this? Dora. In Chennai, many Anglo-Indians' name is Dora. And there was also a cartoon called Dora. You might have seen some children watching like 20 years back. This is how you can remember the sequence of message that has been shared. So what we have seen is this scenario, the first scenario. Next, we will be seeing this scenario with a relay agent. The server is behind somewhere, behind a router, not in the same local area network. Right, we'll do this in the next part. Any question on what you have learned now? Oh, right, which means you're comfortable.